Today in class I'm asking you to watch a video introducing molecular compounds. This is the other main grouping of compounds formed that we'll talk about in class. And so you're expected to watch this and complete the practice problems while I'm out. The learning objectives for today are that the first thing is that you can tell the difference between ionic and molecular compounds. Second, you should be able to write chemical formulas for molecular compounds provided two elements. Third is that you can write the chemical formula given the molecular compound name. And lastly, you can write chemical names for molecular compounds. So what exactly are molecular compounds? Molecular compounds are composed of two or more nonmetals, and they share valence electrons to create a stable, larger molecule. This is different from ionic compounds in that ionic compounds give or take electrons and form ions that are stable in that way. The other name you'll hear molecular compounds called is covalent compounds in this class. And the last thing to remember is that molecular compounds, when you dissolve them in water, they don't dissociate or break apart into the ions that make up them like an ionic compound does, because this is a sharing of electrons. So they do not conduct electricity. In nature, a lot of nonmetals are rather unstable on their own and seek out electrons where they can find them. And so these elements are what are referred to as diatomic elements, because they'll naturally form a pair of atoms when left to their own devices. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine will form diatomic elements on their own. So how can we form molecular compounds from the elements? The first thing is to determine the number of shareable valence electrons for each nonmetal. So for example, if I have, let's say, sulfur, okay, and I have chlorine, all right? Well, we can go to the periodic table and we can look up how many valence electrons sulfur has and how close it is to 8. So sulfur has 6 valence electrons and needs 2 more to get to 8 in an ionic compound. And those 2 that it needs, it's also willing to share. So we would write the number 2 above to indicate that it has 2 valence electrons that it's willing to share for. Chlorine, on the other hand, has 7 valence electrons on its own. And so it only needs 1 more, and so it has 1 valence electron that is willing to share. By sharing, both of these will get to their 8 valence electrons. And so what we can do is we can cross-multiply this here to get us to the number of atoms of each that's needed. And so this becomes SCl2. And if we were to draw this, what that would look like is we would have sulfur here, and it has 6 valence electrons on its own, and each of these chlorines has 7. Alright, and then by sharing this, what's going to happen is we're going to form what's called a single bond between each of the chlorines. And a single bond is a sharing of 1 electron from each, so a total of 2 shared electrons. And if we go ahead and count this then, the bond that's been drawn counts for both sulfur and chlorine. So chlorine has 6 dots and then has 1 line, and that's the additional 2, so it is 8. Sulfur has 4 dots and then 2 single bonds, and so that gives it 8. And the other chlorine has 6 dots and 1 bond to give it 8. And if we needed to, we would then look and see, can I reduce this any more? So an example of that would be the following. So if we had carbon and we had chlorine. So let's not do carbon and chlorine. Let's do carbon and sulfur. So carbon has 2. Carbon has 4 valence electrons that it needs. Sulfur needs an additional 2. So if you were to cross multiply, you would get C2S4, and we can reduce that to CS2. How do we form a covalent compound from the name? Well, just like ionic compounds, you would identify the symbols from the names. And so if we took, for example, carbon dioxide, okay, we know that we're dealing with carbon and oxygen being O. And then you need to look at the prefixes that are included. So carbon doesn't have a prefix before, and we'll go over prefixes in a minute. And so it just has a single carbon, so we just have to write it. Oxygen, though, has a di in front of it, and di stands for 2, so this becomes CO2. When we are writing this out, then, it's just important to double check your prefixes that go with the symbols. The last part of this is how do we name covalent compounds from the formula. Alright, so for example, if we had N2Cl5, which is not a real compound in this case, but we can name it as is. We notice that we have 2 nitrogens and we have 5 chlorines. So unlike ionic compounds where you don't indicate the number, covalent compounds we have to indicate the number of atoms because you can form much larger compounds by just repeating units of it. So in this case, nitrogen has a 2, and so that becomes dinitrogen. And chlorine has a 5, so that becomes pentachloride. On the next slide, I will have the additional prefixes, but just like with ionic compounds, remember that you change the ending to an IDE. Last part of this here is all the compound prefixes. So mono, 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9, and deca is 10. When you are naming covalent compounds, the first element, if there's only one of them, you don't have to include mono. Okay, so for example, carbon dioxide is just CO2. Carbon monoxide, though, indicates that there's only 1 oxygen. Alright, for the rest of the class, what I have for you guys to work on is you have some practice problems, and as a quick reminder, you will have a test coming up next Tuesday in class, so you need to be studying both ionic and covalent compounds for that and reviewing the mole, and I'll put up more practice material for that. Good luck, and thank you.